When you look at a crime map, one thing jumps out immediately. It's not random. Crime clusters, certain blocks, certain corners, certain nights, they light up over and over again. And that pattern has fascinated criminologists, statisticians, and police analysts for decades. Today on Curious Modeling, we're diving into the science behind those clusters, how hotspots form, what they mean, and why understanding them is key to both prediction and prevention. The idea that crime clusters in space isn't new. In fact, the roots go back over a century to early sociologists like Shaw and McKay, who mapped juvenile delinquency across Chicago in the 1920s. They found that certain neighborhoods, especially those near downtown, had consistently higher crime rates, even as the populations living there changed. The takeaway: it's not just who lives in an area, but what kind of environment it is. That was the birth of environmental criminology, the idea that physical spaces shape opportunities for crime. So what exactly is a hotspot? In analytics, a hotspot is a spatial cluster, an area where crime occurs significantly more often than we'd expect by chance. Hotspots don't just show where crime has happened, they show how it behaves. They can be short-lived, like a 2-week wave of car break-ins near a stadium, or long-standing, like a block that consistently shows up in police reports year after year. Crime analysts identify these clusters using statistical techniques like kernel density estimation, GI statistics, or spatial autocorrelation. Each method answers the same question in a slightly different way. Is this pattern random, or is there something systematic happening here? Let's break down the math just a bit. No equations, just the concept. Kernel density estimation, or KDE, takes each crime location and spreads it out like a small hill of probability. Where those hills overlap, the surface rises. That's your hotspot. GI statistics, on the other hand, doesn't smooth data. It tests whether neighboring locations have values higher than expected. If they do, that area gets flagged as a statistically significant hot cluster. These methods might sound abstract, but they're basically ways of quantifying what your eyes already see. The crime tends to bunch up, but hotspots aren't just about space, they're also about time. Criminologists talk about near-repeat victimization. The idea that once a crime happens in one place, nearby locations are more likely to experience similar crimes soon after. A burglary today increases the odds of another tomorrow, sometimes because the same offender returns, sometimes because others notice the opportunity. That's what turns a single event into a cluster. It's not random, it's contagious. Modern hotspot models combine this spatial and temporal logic. They're not just mapping where crime has been, but forecasting where it's about to move next. So why do hotspots form in the first place? Researchers point to 3 main forces. The first is opportunity. Some places simply offer more chances. Unlocked cars, busy bars, poor lighting. The second is routine activity theory. Crime happens when a motivated offender, a suitable target, and a lack of guardianship all meet in the time and space. The third is environmental design. Layout matters. Visibility, access routes, and boundaries all shape how crime flows. Hotspots, in that sense, are like urban fingerprints, patterns that reveal how people, spaces, and systems interact. Now here's where it gets tricky. A hotspot map might show more crime in one neighborhood than another. But remember, these maps often reflect where crime is reported or recorded, not necessarily where it occurs most. If police patrol one area more intensively, they naturally detect more incidents there. That doesn't always mean there's more crime. It means there's more visibility. So, when we use hotspot maps to allocate resources, we have to ask, are we mapping risk, or are we mapping attention? Hotspot science doesn't just belong to law enforcement. Urban planners, sociologists, and public health researchers use the same spatial methods to study things like traffic accidents, overdoses, and even mental health crises. The same math that predicts where burglaries might happen can also show where new streetlights, after-school programs, or housing supports could make the biggest difference. Predicting crime isn't the goal. Understanding patterns and using them to build safer, fairer spaces is. So the next time you see a crime heat map in the news, look closer. It's not just a picture of risk. It's a story about opportunity, behavior, and the design of everyday life. Hotspots tell us that crime isn't evenly distributed. It's concentrated, predictable, and, most importantly, changeable. In our next episode, we'll explore what happens when those patterns shift from places to people, the rise of person-based prediction, and the ethics of risk scoring.